Okay, today we are going to start Chapter 3. Okay, that's the first page of your notes. We're starting Chapter 3. In Chapter 3, we are going to have a couple different strategies to solve systems of equations. That's what Chapter 3 is, solving systems of equations. Before we start with solving and telling you how to solve systems of equations, we're going to talk about what are systems of equations. Okay? Very easy. Systems of equations are a set of two or more equations with two or more letters. That's what they are. You have two or more equations with two or more letters in them. I have some examples of them for you, and if you notice, I'm going to look down here to solve the system. If you've got two variables, you're going to need two variables if you've got two equations. If you have two equations, you will need at least two variables to solve them. If you have three variables, you're going to need at least three equations. Three variables, three equations. Two variables, two equations. Four variables, four equations. Don't fret, because we are not going to solve the 3x3's or the 4x4's. In this chapter, we're only going to solve the 2x2's. The reason we call them 2x2's is because two variables, two equations. Right. Here's another one. 2x2 because he's two variables, two equations. Okay. So what is important for you to understand when we talk about what's a solution? A solution to a system of equations is a set of variables that makes the equations true. Okay, so that's what we're looking for. We're looking for values that make both of those equations true. And to solve them, that's what we're going to do. We're going to find values that make the equation, each equation, true. Okay, that's important. So when I say solve the system, and if we're looking at x and y, you're going to find the x and the y that make them both true. Right? And I'm going to show you three different ways. And the first way we're going to do today is solve by graphing, because we just finished graphing lines, correct? Y equals mx plus b. So it's the way you're most familiar with, because you all know all about solving for y and slope-intercept form. We're going to do that. So go to the next slide. Oops. That's the same thing. That's the same thing, don't you? I got the slides on there twice. Yeah, you got it. All right. You got that next? All right, I'm going to have a couple slides on there. All right. That's all we're going to do. These are just kind of a repeat of what I did. The goal is to find. Okay, here's our goal. Our goal, you're going to find a value for x and a value for y that work in both equations. Okay, that's our goal. That's what we're going to do. So I say solve the system. That's what you're going to do. How we're going to do that? Well, today, we have an x and a y. An x and a y are lines, aren't they? So see these equations? Those were the example that was on that slide from before. And if we're going to solve those equations, those are just equations of lines, aren't they? What we're going to do is we're going to solve them, and we're going to graph them using y equals mx plus b. We're going to see where they meet. Okay? All right, so let's start. So for that first problem, the first method, again, that we're going to do for solving the equations, the system of equations, is graphing. They're both lines. We're going to graph them and see what they mean. You have questions?
You're just like doing functions, like
Just graphing, like y equals
function
mx
charts
plus b.
and graph.
Nope, just solving for y and graph them. You're not even doing the xy chart. We're not even doing xy charts.
Oh, so it's like y and...
Yep, it's just like y equals mx plus b. That's exactly right. Just the stuff that we did. So what I'm going to do is I'm going to take this first one and I'm going to solve them in green, and I'm going to graph them in green. And the second one I'm going to solve them in blue, we'll graph them in blue, and we're just going to see where they meet, if they meet. So let's do that. So let's take the first one. This y, or x plus y, is equal to 3. And if you solve him for y and make him look like y equals, what do I do? What do I do? I'm solve him for y. Right, minus x. Okay. You can either minus x, or some of you guys, I know you like to do minus 1x. Either way, that's okay. Okay. And when I do that, what am I going to get? My x's are gone, and I get y. I'll do the easy part. Y equals, now, I don't want to write 3 minus 1x. I want to do it, I want the x first. Okay. So I'll do this one. even though I told you I did. So is that okay? I've got y is equal to negative 1x plus 3. Do you remember how to graph them? Do you remember how to graph that line? I have my first point. I have a point and a way to get more points. Where's my first point? Where do I look to first? Remember?
3.
Yep, the 3. Good job. So you look to your 3 because that is your y-intercept. That's your first point. So if you go to positive 3 on your y-axis, that's your first point. How do you think I get more points? Yep, I go to the negative 1. What's the negative 1 tell me? What is that? What does that negative 1 mean? What is he? He's the slope. And if I were doing a slope, slope is what over what? Right, rise over run. So if I'm doing a slope and I have my rise, now he's not a fraction. How can I make him a fraction? I need a rise over run. Yeah. Gonna put him over 1. Now he's a fraction. If he's not a fraction, make him a fraction. Put him over 1. So when I go to my other points, and I need other points, I'm going to go down 1 and right 1. Down 1 and right 1. And if you want to put another point on there, you can. Just make sure you count it correctly. And remember, he should be going downhill. He's got a negative slope. He should be going downhill. So I'm going to back in and make him green. So let me make him green. Make him green. I might make him a little thicker too. Let's make him a little thicker, and I'll make this guy green. Oh, don't forget your arrows. I'll just draw them on. For the next one. The next one we're going to solve him. I'm going to write him in blue down to 5. You know what? Let me make him in red. Scratch that. Let me make him in red. Blue's too much like red. Okay, so I'm going to make this other one in red, and he's x minus 2y equals 0. I'm going to do the same thing. I'm going to solve him for y. So what do? At 1x. If you want to make him 1x, you can. If you want to leave him minus x, you can as well. I know a lot of you guys like the 1 in front. That's fine. So when I do that, I've got negative 2y is equal to negative 1x plus 0. He's not quite solved for y. What do I do to solve him for y? Good job. Divide by negative 2. Yes.
Do you have to put that 0?
You don't have to. I just want you to see that he's there because my y-intercept is 0. Okay. So you don't have to put him in there because I know when we were talking about your final line, don't put the plus 0 at the end. If you need him there to remind you that that's where you're going to start, your y-intercept is 0, you can leave him there. So this guy is y equals, is he negative 1/2 x? What's my slope? Positive or negative? Positive. Because, yep, 2 negatives to cancel out. And I can bring my plus 0 down, because remember, 0 divided by anything is just 0. Now the final answer, if I asked for the equation of a line, you wouldn't give me the plus 0, but if you need him there to help remind you, that's my y-intercept. So when I'm graphing this guy, my first point is my y-intercept. He's 0, so I go to my y-axis, put the point on 0, and is my line going uphill or downhill? Uphill. Tell me how much I rise. I rise how many? 1, and I run how many? 2. Good job. So I rise 1, I run 2. I already see where they intersect. I'm going to rise 1 and run 2. And if you want to do it again, you can, just to have another point on there. I'm going to connect those. Now when I connect these, and let me make him red. Let me make him red. Whoops, I got a 0, so I draw a 0 this time. Whoops, he's blue. Okay, so when I draw those lines in, and when they intersect, tell me the point at which they intersect. They intersect at what, comma, what?
2, 1.
2, 1. Good job. They intersect at 2, 1. What that means is, if I go back to the original equations, I'm going to scroll up here. If I go back to the original equations and put 2 in for x and 1 in for y, they'll both be true. Let's see if it works. You don't have to do this for all of them, but we just want to see. That's one way to get them. Okay, so if I put a 2 in for x in the first one and a 1 in for y, is it true?
Yeah.
Yep. Okay. Let's try with the other one. Let's try with the red one. And again, I'm going to put a 2 in for x and a 1 in for y. Is it true?
Yeah.
Yeah, because he'll be 2 minus 2. And he is 0. So that's what you're getting. So when you solve a system of equations, you're telling me the values for x and y. I'm getting the values of x and y that make both those equations true. One value for x, one value for y. You okay with that? Let's go to the next one. Another one. We're going to do the first one, and he's going to be x plus 2y equals negative 2. Tell me how to solve them. What do I do?
Minus.
Yep, minus x. Minus x. And I'll do the easy part. I'll take 2y equals. You tell me what to do. Negative.
Negative 1.
Right? Negative x minus 2. Because remember, I can't combine them. They're not like terms. So my x is one thing and my y or my plane number is another. He's not solved for y yet. What do? I don't want 2y equals. I want y equals. So what do I do?
Divide by 2.
Yep, I divide by 2. Everything is divided by 2. So I get y is equal to, what's going on? What's x over 2? What is that? Is there some number really there?
Yeah.
Yeah, there's a negative 1 really there. So isn't he just negative 1/2 x? Good job. He's just negative 1/2 x. So what about my plane number? What about my negative 2 divided by 2? Yep, negative 1. Good job. Exactly right. Okay, I'm going to go to the y-axis. Where do I put a point on the y?
Negative 1.
Yep, negative 1. Be careful. That's your sign. Remember, he's my first point. How do I get more points? I'm going to go up, down, left, or right, and how many?
Down 1.
Down. Very good. Down 1, right 2. Down 1, right 2. Again, he is a negative slope, so he should be going downhill. Whoops, he's not very good. I got to make him straighten him up a little bit. Not looking at the point with it. And then we will make him red and a thick line. And we'll put some arrows on the end of it. Good so far? Let's go to the other one and solve the other one. Okay, we'll do him in green, except I don't know what his is. I can't see him. Let me scroll back up a little bit. So the other one is 3x minus 2y equals negative 6. How do I solve him? Remember, you move your x first, okay? So you're going to move your x first. Be careful, you subtract from both sides. So you're going to move your x first. You get negative 2y is equal to, make your x go first, negative 3x minus 6. Now what?
Divide by 2.
Divide by negative 2. Good job. You're going to divide everything by negative 2. That's going to give me y equals, tell me what my x is. I got a negative 3 on top and I got a negative 2 on the bottom. Give me a hint. Oh, right. These 3 halves. I want to keep them a fraction. Remember? I need a rise over red. I need something over something else. When he wasn't a fraction, I made him a fraction. But he is. Okay, what about the plain number? What about that negative 6 over negative 2? What's happening with that? Good job. Positive 3. You okay with that one?
Mm-hmm.
Okay. Let's graph that guy. I'm going to scroll back up a little bit. Where's my first point? I'm going to go the x or y-axis. Y, good job. He's my y-intercept. So I'm going to go to the y-axis. I'm going to go to positive 3. And up, down, left, right, and how many? For my next point. Which direction?
Up 3 and right 2.
Good job. Up 3 and right 2. So I'm going to go up 3 and right 2. So I'm going to go up 3 and right 2. Up 3 and right 2. Now, if they don't meet, because right now they don't meet, I might have to go back down the other way. So I might have to go down 3 and left 2 so I can figure out where they cross. So is that all right? You might have to go back down the other way So if you can't see where they cross, you'll just have to add some points on going the other way. Let me make this guy green and put some arrows on him. Then you can tell me where they meet. Good job. -2, 0. Right. So they meet. They meet at -2, 0. Again, those are the values for x and y that make them both true. Any questions on that one? All right. We got a couple more. Now let's try this one. All right, I have x minus 2y equals -2. Tell me what to do. What am I going to do? Subtract 1x from both sides. Again, if you want to call it 1x, because I know a lot of you guys like to do that, to leave the 1 there so you can see what the slope is, you can. Okay, so I'm going to bring down -2y is equal to, remember, make your x go first. So he's -1x minus 2. What's my next step? Somebody tell me. Yep, divide by -2. Good job. When I divide by -2, he's going to be y equals, what about the -1 on top and the -2 on the bottom? What's with that? Yep, he'll be positive. He'll be positive 1/2 x. And what about the -2 over -2? What's he? Positive 1, so he's +1. Awesome job. Let's graph him. My first point. I'll do the easy part. Remember, he's my int. I'm going to go to the y-intercept. I'm going to go to the y-axis and put a point on +1. Tell me where the next point's going to go. From that red point, do I go up, down, left, right, and how many?
Up, right.
Right, up and right. So I'm going to go up 1, right 2. Up 1, right 2. A couple, 2 or 3 points on there's fine. Oops. And connect them. And make them red. Oops, arrows on it. Almost forgot my arrows again. And my other one. Let me scroll down a little bit. My other one is 3x minus 6y is equal to 6. Tell me how to solve him. What do I do to solve him? I want to move my x first. Remember, move your x first. So I'm going to subtract 3x from both sides. He's going to be a -6y. Make your x first. Not 6 minus 3x, so -3x plus 6. And what am I going to divide by? You tell me. Good job. Divide by -6. Divide everything by -6. What does that give me? I'll do the easy part. I'll do the y equals. What about that -3 over -6? What's that? Positive 1/2. Good job. And what about that positive 6 over a -6? What's he?
-1.
-1. Good job. He is -1. How's that? Everybody okay with that? So the equation of that line is y equals 1/2 x minus 1. I'm going to move back up here so I can graph him. Okay. I'm going to put a point here on -1. I'm going to move him up so I can see. Okay, now, which direction do I move and how many? From that point, I'm going to go,
Up 1, over
correct, up 1,
right.
right 2. Up 1, right 2. Well, if you notice, if I keep going, what's going on with those two lines? They're, good job, they're parallel. What do you think is going to happen when they're parallel? What do you think is going to happen when they don't meet?
They're just going to keep going.
Is there an answer?
No.
Nope.
No, there's no answer. That's how no solution shows up. No solution will mean, yeah, they don't meet. So they will be parallel. That's a no solution. So let me make this guy green and make him a little bit thicker than that. And we'll put the arrows on him. So when you have parallel lines, when your lines are parallel, they are a no solution. Okay? There's no x and y to make them both true. They don't meet. They're parallel. There's no x and y. There are no solutions. In a minute, we're going to talk about some special words that we use for if they meet or if they don't meet. But first, I'm going to do the very last example. Anybody have any questions on that one? Okay. This last one. I'm going to take the first one, we're going to solve it. So let me rewrite this first. X minus 2y equals negative 4. Solve him for y. What do you do first? Yep, minus x. If you want to write minus 1x, you can. And I'll do the easy part. Negative 2y equals, tell me, negative 1x minus 4. What do I divide by? Negative 2. So you're going to divide everything by negative 2. Be careful, watch your signs. Everything's got to be divided by a negative 2. Okay, so starting with that negative 1x over negative 2. What is negative 1 over negative 2? Positive 1/2 x. Yep, it's 1/2 x. Now what about the negative 4 over negative 2? What about that?
Negative 2.
Negative 1 or 2.
Oh, negative or positive? What did you talk about?
Positive.
Very good. Positive 2. Good job. So let's graph that guy. First point is my y-intercept. So remember, go to the y-axis, put a point on negative 2, and tell me which direction and how many.
Up 1, right 2.
Good job. Up 1, right 2. Up 1, right 2. We can put a couple more on there. Graph them, connect them with a straight line, and I'll make that line red. Arrows on it. Now, I'm going to do my 3x minus 6y equals negative 12. To solve him, what do I do? Good job. Subtract 3x from both sides. So subtract 3x from both sides. I'll do the easy part. Negative 6y equals. Am I going to write negative 12 minus 3x? No. What am I going to write?
1
Make your x go first. Negative 3x minus 12. Okay? Just make your x go first. You're just making the x first. That's all. Now what? What do I do now? Thank you. Divided by negative 6. Good job. Okay, so when I do that, I get y equals, what about that negative 3 on top and that negative 6 on bottom? What is he? Yeah, that's right. He's 1/2 x and he's positive. And what about the negative 12 divided by negative 6? What is he? He's positive 2. So he's plus 2. Do you notice something?
Same thing.
Same thing. They don't meet, they're the same thing. When they're the, yeah, same line. When they're the same line, that's how an all, whoops, I can't write same. When they're
All solutions?
Yep, that's exactly right. They're an all solution. So when they're the same line, they're an all solution. So all reals. Can write that funny R. Yep, they're the same line. Yeah, they're the same line. Because you're like, oh wait, I don't have to graph that. They're the same line. I just graphed 1/2 x plus 2. I just graphed it. Now here's what I want to do. Now that we've talked about either the lines cross, there's only 3 things can happen. They either meet at a point, and you can tell me where they meet. They meet at 1, 2, or 3, 4. Or they don't meet at all. Or they're exactly the same line. So we're going to use some words. And here's what they are. Okay, so it might ask you in your book, describe, graph the following and describe the solutions. If they meet, you're going to tell me the point at which they meet, whatever, comma, whatever. And you're going to tell me the words, it is consistent and independent. Those are the words. Consistent means I can give you at least something that works. If they're the same line, they're consistent, because again, I can give you at least something that works. And they are dependent. And if they don't meet at all, they're parallel, it's called inconsistent. Inconsistent means nothing works. Do you have any questions on those? Your book assignment is on the very next page. So if you want to start on that, we can. I got some graph paper and I will